The acceleration is the rate at which the velocity changes. So we're looking at how much does the velocity change over time. So it can be a change in speed or even a change in direction, which can make that acceleration or deceleration have a value to it. So positive acceleration is when we're going to be speeding up. Negative acceleration, we're going to be slowing down. And we're going to use the following formula to calculate the acceleration. So acceleration, which is A, is equal to the final velocity minus the initial velocity divided by the time that it took. And they also provide a triangle here that you can use for solving. So we're going to solve for the acceleration here. A roller coaster starts down a hill at 10 meters per second. So I see the word starts. That's going to tell me that that's the initial velocity. 3 seconds later, there's your time. Its speed is 32 meters per second. So there's our final velocity. And it wants to know what is the roller coaster's acceleration. So I'm going to write out my givens that I was given. So my initial velocity is that 10 meters per second. The time that I was given was 3 seconds. And the final velocity that it reached was 32 meters per second. So I'm going to go ahead and write out my acceleration formula. So acceleration is equal to my final velocity minus my initial velocity divided by time. And I'm going to fill in the numbers that I was given. So acceleration is equal to my final velocity is 32 meters per second minus the 10 meters per second that I was given as my initial velocity. And that's going to be divided by the 3 seconds on the bottom. So in order to solve for this, you're going to want to do the top first. So I'm going to want to simplify this top part before anything else. So I'm going to do 32 minus 10. And that's going to give me 22 meters per second on top. And that's still going to be divided by the 3 seconds. So I'm going to take that 22, and now I'm going to divide it by 3 to get an acceleration of 7.3. And the units for acceleration are meters per second squared. And now let's do another one. So how long will it take a car traveling 30 meters per second to come to a stop if its acceleration is -3 meters per second squared? So in this one, we are looking for the time. How long will it take? So that's going to be our time. That's our unknown. We are told that the car is initially traveling at 30 meters per second. So my initial velocity is 30. And it wants to know how long it's going to take to come to a stop. So that means my final velocity is actually 0 meters per second. They want to know how long it takes to not have any velocity at all. It says that the acceleration, A, is equal to -3 meters per second squared. So that's going to be our acceleration. So now I'm going to write out my formula. Acceleration is equal to the final velocity minus the initial velocity divided by time. And I'm going to plug in my numbers that I was given. So my A is -3. My final velocity is 0. My initial is 30. And the time is what we're looking for. Now to solve for this, you have to do quite a bit of algebra. So the first thing I'm going to do is get rid of t on the bottom. So I'm going to multiply both sides by t so that it cancels out on the right-hand side. So now I have t times -3 on the left is equal to 0 minus 30 on the right. I'm going to simplify the right-hand side. 0 minus 30 is -30. And that's equal to the t times -3. To get t by itself, I'm going to divide both sides by the -3. And I'm left with t is equal to that -30 divided by -3. When I divide -30 by -3, I'm going to get a positive 10. So it took 10 seconds for that car to come to a stop.